Today we're going to do an Algebra 2 lesson on the transformations of quadratic functions. Starting off with a quadratic function is any function that can be written in the form f of x equals a times the quantity x minus h squared plus k, where a does not equal to 0. The values a, h, and k are all constant. This form is called a vertex form because the vertex is going to be the point defined by the horizontal and vertical translations h and k. Remember, when we're working on translations, the h is a horizontal translation and the k is vertical. So the vertex then is going to be the ordered pair hk. The graph of a quadratic function will be U-shaped, and that graph is called a parabola. Okay, so let's jump right into some of our transformations here of f of x equals x squared. We want to describe the transformations of a graph f of x equals x squared. This is our parent function. That's going to be represented by the function g of x equals quantity x plus 4 squared minus 1. And then we want to graph each of those functions. So first off, as I go from f of x to g of x, notice that I have moved to the left 4 and then down 1. So our description of our transformation is that it's a translation that moves to the left 4 units and down 1 unit. So in order to do a graph of this new function g of x, let's start with our graph of f of x equals x squared. And let's get that graph by doing a table of values. And we're just going to use -2 to 2 for our values of x. And in each case, we're just going to square those values. So we start off by putting -2 in for x. When we square a negative, of course, we get a positive. And then -1 squared becomes 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So let's go ahead and graph those points. We have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. A nice U-shaped graph. The vertex of this U-shaped graph is at the origin is at 0, 0. Now we want to take this graph and we want to translate it. We want to move to the left 4 and down 1. So we're going to take each one of these points that we graphed here from our table and we're going to move them left 4 and down 1. So we're going to go to this point and I'm just going to count to the left 4 and down 1 and mark that point. And I'm going to do that with our next points as well. Left 4 and down 1. The whole graph is just translated and moved left and down. So we have a new U-shaped graph. It's exactly the same shape. It's just in a different position on the graph. Now, a couple of features of the parabola that stand out are the vertex and the line of symmetry. We want to identify the vertex and the line of symmetry. For our original graph, for f of x, our vertex was at 0, 0, and our line of symmetry was right down the middle of the graph, which is the y-axis, which is x equals 0. For our new function, g of x, the vertex is shifted. It's shifted to the left and down. So our new vertex for g of x is going to be the ordered pair -4, -1. The line of symmetry is also shifted to the left instead of right up the middle of the original graph there on the y-axis. It's also been shifted to the left 4. So our new line of symmetry is here. And that's the equation x equals -4. Let's do another example. Our next example, again, we're going to start with the parent function f of x equals x squared, and our new function g of x is equal to -1/2 x squared. So we want to describe those transformations, and then we're going to graph. So as I look at our transformations, I see I have a negative, and then I have a 1/2. So we have two things going on. The negative tells us that we have a reflection, and this reflection is in the x-axis. It's across the x-axis. And then we also have this factor of 1/2, which is a vertical shrink of 1/2. Okay, so I've already got the graph of y equals x squared that we had graphed on our previous page, and we had a table of values with it. Let's take a look at what our transformations do. A reflection in the x-axis is going to turn, just reverse it upside down. It's going to take all of the y coordinates and make them their opposite. So let's go ahead and do that. We're just going to take each point, we're going to reflect it over the x-axis, which is just going to make each point here, the y-coordinate here is 4, reflect it, the y-coordinate is now -4. A y-coordinate of 1 goes to -1. When the y-coordinate is 0, the opposite of 0 is still 0. It stays right where it is. And our other points, 1 reflects to -1, 4 reflects to -4. And we have a nice U-shaped graph. This is just step 1 in our transformation. We did a reflection in the x-axis. Now let's take that, and we want to do a vertical shrink of 1/2. That means all of the y-coordinates are 1/2 as large. So we're going to take all of our y-coordinates in our reflected graph and multiply them by 1/2. So here we have a y-coordinate of -4. -4 times 1/2 is -2. And -1 times 1/2 is -1/2. 0 times 1/2, still 0, stays right where it is. -1 times 1/2 is -1/2. And again, -4 times 1/2 is -2. Each one of those y-coordinates is half as large. And now we have our new graph here. And so our graph g of x is represented by the orange graph, which has those points. Okay, now identify the vertex and the line of symmetry. In our original graph, we had already identified the vertex and line of symmetry. The vertex was 0, 0. The line of symmetry was x equals 0. Notice when I flipped this graph over and shrunk it, the vertex remained unchanged. It didn't move left or right, so our line of symmetry is also unchanged. So for g of x, our vertex remains 0, 0, and our line of symmetry remains x equals 0. Now let's do one that's got a couple of different kinds of transformations in it. In this next example, I'm going to describe the transformations again, starting with a parent function of f of x equals x squared. This time g of x, we have 2x in the parentheses, then squared, then plus 1. Because we're inside the parentheses before we square it, I've changed the x before I do the square. This tells us that this is a horizontal transformation. In fact, it's a horizontal shrink. And our factor for our shrink, remember, is the reciprocal of our coefficient here. So it's a horizontal shrink of 1/2. And then the plus 1 is a translation up 1. Okay? So let's do these transformations. We're going to start with our horizontal shrink of 1/2. that means each x coordinate is going to be multiplied by 1/2. So let's take a look at this point on our graph. The x coordinate is -2. So multiplying -2 by 1/2 makes it -1. It's shrunk. The x coordinate is back towards the center. Okay, an x coordinate here of -1 multiplied by 1/2 is -1/2. X coordinate of 0, 0 times 1/2 is still 0. Our y coordinate, or our x coordinate of 1/2, our x coordinate of 1 multiplied by 1/2 is 1/2. And finally, our x coordinate of 2 times 1/2 is 1. So this new graph with our horizontal shrink is squashed horizontally. These points have moved in towards the center. So this is our first step in our transformation. Now, our second step is to do a translation up 1. So I'm going to take all of the y coordinates, because this is a vertical translation, I'm going to take the y coordinates and move them up 1. So our y coordinate moves up 1. And our y coordinate up 1. Even the vertex moves up 1. All of our coordinates move up 1 to give us our new graph right there. That's our blue graph. That's our g of x, and it's here. Okay. Identify the vertex and the line of symmetry. Well, our vertex was at 0, 0. It moved up 1. So our new vertex for G, our vertex is now at 0, 1. Our line of symmetry is still in the same place. It hasn't shifted to the left or right. So our line of symmetry is x equals 0. Let's go to writing an equation from a description. In this case, we have G is going to be a graph or a function that it's resulted from a transformation that's a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down. And the transformation is going to be applied to f of x equals x squared. We want to write a rule for G. And after we do that, we want to identify the vertex and the line of symmetry. So let's start with our function f of x. We're going to use the rules of transformations that we've been working with this year. So f of x equals x squared. And we're going to have a preliminary step because our first step is going to be a vertical stretch of 2 and a reflection in the x-axis. Both of these two transformations affect the y-coordinate. So we're going to call that our function h of x is going to take f of x. The stretch is going to take f of x multiplied by 2, and the reflection is going to make that negative. So we can do that in one step here. So our new function, which is our transitional step, -2 times f of x, or -2 times x squared. So that's step 1. Now to get to step 2, to get to g of x, we're going to take h of x and we're going to do a translation 3 units down. So from our transitional step h of x, we're going to go down 3. So our g of x, our second step here, is our h of x, which is -2x squared minus 3. A second method to do that is to identify how the transformations affect the constants in the vertex form of a quadratic function. We had y equals a, x minus h squared plus k. We learned earlier that the h and k change the vertex. So these affect the vertex. Okay. The A, we can look at it and we can see that the A is going to affect vertical stretches and reflections. And since this follows the order of operations, we want to do a vertical stretch or reflection first, followed by translations to the left or right or up and down. And that is the description what we have here. We have our vertical stretch and reflection first by a factor of 2 with a reflection on a negative. So our A becomes -2 because it's a reflection and a stretch. Our H was not changed at all. Our K was moved. So our H remained 0 and our K was -3. So using those in our equation, we have y equals, or g of x equals, -2 x minus 0 squared minus 3. So our new function g of x is -2. X minus 0 is just x, and square it becomes x squared minus 3. We get the same values. With method 2, it's important that we identify what order the functions are going in so that we make sure that we've got the right values for both A, H, and K. Okay. Almost done. 2 more examples. Let's do another one very similar to our last one. We're going to have G as a translation, 3 right and 2 units up, followed by a reflection in the y-axis. And this time we're starting with a different parent function. We're starting with f of x equals x squared minus 5x. We want to end up with a rule for G. So let's take a look at our first step. The first step is the translation, and it's 3 right and 2 up. So let's take a look at that. If I'm going to have a function f of x that is moving 3 right, then I'm replacing x with x minus 3 and 2 up, and I need to add 2 to the end. So our h of x is going to be replacing all of our x's in here with x minus 3. We're going to have x minus 3 squared minus 5 times the quantity x minus 3 plus 2. And then I'm going to move it, or I did that, the plus 2 is moving it up 2. Okay. Now, simplify. We have a binomial, x minus 3, and the quantity is squared. Just as a quick review of how to multiply out a binomial, we're taking the binomial multiplied by itself. The quick, easy way is to remember the acronym FOIL. We're going to do first, outer, inner, and last. So when I multiply that out, I get x squared minus 6x plus 9. So that's our x minus 3 quantity squared becomes x squared minus 6x plus 9. And then distributing on, expanding on our rest of it, we have negative 5x plus 15 and then plus 2. Combining like terms, we have x squared minus 11x plus 9 plus 15 plus 2 is 26. Okay, that's step 1. That accomplished our translations and then simplifying our transitional function. Now we want to follow it by a reflection in the y-axis. So for our next step, a reflection in the y-axis replaces x with negative x. So I want h of negative x. I'm going to replace all the x's in h of x with negative x. So I have negative x quantity squared minus 11 times negative x plus 26. So our g of x, our function that we're looking for, becomes x squared plus 11x plus 26. Remember, when you square a negative, it becomes a positive. Okay, one last example we're going to do. We're going to actually look at a Desmos modeling to help us with this one. It says the height in feet of water spraying from a fire hose can be modeled by h of x equals negative 0.03x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. And the crew is going to raise the ladder so that the water hits the ground 10 feet farther from the fire truck. Okay, so we want our x to be out 10 feet farther. We want to write a function that models the new path of the water. Well, we're raising the ladder, which means this is our h of x is going to get moved up so that I can extend the path of the water 10 feet farther. To model that, let's take a look at Desmos. So we're going to move to a different share on my screen, and we're going to go to Desmos, which is here, and I'm going to enter that equation that we were looking at. It was negative 0.03 x squared plus x plus 25. So here's our graph. As we look at our graph, our 0 here represents the distance from the fire truck. And our height on this point is the height of our ladder, or the initial shooting up of the water. So right now we have a ladder at 25 feet high, and the water is going up in a path, and it's coming down here. This is the only portion of the graph that makes sense on this problem. Okay? Can't have a negative horizontal distance from the ladder, and we can't have the water going below the ground. So we're just looking at our first quadrant. We want this water not to hit the ground 50 feet from our truck. We want it out here so that it hits 10 feet farther. We want it out here at 60 feet from the truck. So what we're going to do is we're going to move our ladder up. We're going to move up and see how far we need to move that ladder up so that our horizontal distance is changed. So let's do that. Let's take our equation and copy it, and let's move it up 10 feet. Okay? And when we did that, we moved everything up 10. Notice that we now are at a point here. Okay? So we've hit the ground about 5 feet farther out. I think we need to move our ladder up a little bit more. Instead of 10 feet, let's try 20. We're getting closer. We're starting up here at 45 feet high. The water goes up in an arch, comes down and hits the ground 58.83 feet from the truck. Needs to be a little bit more. How about 23? Let's see how we did. There we go. The ladder hits the ground now at 60 feet away from the truck, 10 feet farther than this one. And so we've figured out how much higher we need to move our ladder. We need to add 23 feet to our ladder. So this gives us our new function that we're looking at. Let's record that. I'm going to go back to my camera. And we have here, we moved it up 23 feet. So our g of x is going to be negative 0.03x squared plus x plus 25 plus the 23 feet further we went, or g of x equals negative 0.03x squared plus x plus 48. And that's our lesson on transformations of quadratic functions.